So just to set a bit of expectations here, it's a very simple talk. It's a beginner's talk. It's code heavy. C#, I apologize. Or maybe that's good, I don't know. So that's kind of to frame things. Design in the small. When I say that, what do I actually mean by that? Well, this talk is more focused on the local decisions that you make. It's not about the big picture, kind of what happens between all our bounded contexts. It's when you're fully entrenched into the model, basically, that you're actually making a lot of decisions there, which I think affect your software. And I may be contradicting in some ways the previous speaker, if you will. But as he said, basically, there's a time and place for everything. So, and I frame these things as tactical practices, right? I mean, it's the things you do, the small things you do, and the local decisions that you make that kind of make up what the result is, what that looks like in code. And one of them is about the primitives in your models. And in 2014, I worked for a startup that was going to build a very big online collaboration platform for more traditional companies. So the kind of companies that are not into tech, but still want to reach out to their customers, their partners. And the novel way, I would say, they approach that, which is not unique for us techies, but is that they kind of came up with bringing people together in special interest groups, if you will. It could be by language, it could be by region, it could be by segment of the market, it could be because you wanted to have a more direct connection to certain types of partners. So the groups we made were the kind of flexible thing that allowed you to set up the software in a variety of ways that would fit your organization. But, I mean, there's some basic functionality associated with this, right? So at some point, you have to write some code. And a very simplistic way of representing this is that you somehow had to create a group in which you would collaborate. And this group has an ID. You associate a name with it because people are not very good with remembering GUIDs. And you also have an objective which kind of states what this group is for. And then the group also has this types thing where, I mean, we had different types of groups. Like we had public groups, which you can find and basically join as you want. And then we had private groups, which you basically couldn't even find. There was by invitation only. So this is a very naive way, I would say, to represent that. And then a usage would be that you initialize this group with data. Now, you want to be a bit more object-oriented about it, so, and protect stuff. So you're saying, well, I'm going to add a constructor to that one. Very basic, right? And again, the usage doesn't change very much if you look at it that way. But if we explore a little bit more in the language, was like, for example, when we wanted to start a private group, it kind of makes sense that there was a concept of a private group. There was a concept of something, the word start was in there, and not a new that was your constructor there. So it also made sense to have kind of know what you were passing into it. So what's a group ID? What's a group name? What's a group objective? That you were thinking about these things in isolation, if you will. And the code changes again, not dramatically, if you will, on the usage side, but ever so slightly, I would say. Now, if we look in that constructor of the previous object, this is what you would typically get. I mean, we're saying that the identifier cannot be empty, the name cannot be empty, that there has a certain length, and if you pass in an objective, then it should have also a certain length associated with it. And, oh, by the way, the group should either be private or public. Now, if we compare the same code in the constructor of the private group, that's the same code. Now, the question is, obviously, where did the code go? How come it's the same code? Well, the code moves. And the code moves to your domain primitives, to your value objects, if you will. And agreed in a language like C#, you have to type a lot of boilerplate to get that going, right? So the equality is present here, and the rule that we had before is present here as well. And you do a similar thing for the name. And already you get a different usage out of that, because if the group gets renamed, we just remove that logic that would also be in the rename, and we move that into this particular object. So if you contrast that, the spreading out of what makes a name basically is localized to some concept within your code base. We have a similar thing for a group objective, but it's inferred from a string value that we pass in. And in this case, we're very simple. I mean, it should match a certain length and not go over that. And then you have an objective. If you happen to pass in null, I do apologize for using null here, then at that point, you basically say, well, you didn't specify an objective. But already, when you're thinking about all these concepts, you're thinking about them very locally to this particular implementation. They don't spread out across your code base. That's one of the values value objects bring. Now, along the line, obviously somebody says, well, you know what, I want people to be able to mark up their objective and be able to set stuff in bold, and again, a very local decision. So you infer it from Markdown, and we start depending on a Markdown parser to parse out the value. We kind of sanitize the document such that you don't insert script tags, which will hijack our data or our security session, if you will. And again, we do the length checks, and it changes a bit. And we start thinking of it, well, we may want to have the old behavior next to the new behavior, which is we're going to introduce a MIME type that says basically the previous behavior was plain text, and this one, Markdown, now will have its own MIME type associated with it. That makes that a little bit easier. Notice also that I've pushed out the parser up, basically. The parser is no longer in my code. I just have a Markdown document that I'm accepting, basically. And we can even take that further. I can just take a sanitized document, Markdown document. That means that I'm actually pushing stuff out of my model that I don't want to be in there. I don't want to be dependent on a Markdown parser. I want to be depending on an abstraction, meaning that something should give me a document that's sanitized, whatever that means, whatever the implementation of that is. But I've been talking about a group objective now for 5 minutes. Notice how it's constrained into this one little class here. It doesn't spread out to all the other usages, if you will. Now, these objects were, these are the training wheels, I would say. It's not that difficult to build these things. It's very easy to criticize whether they're necessary or not. In 2010, I worked on a project for 4 years that involved scheduling appointments in hospitals. And let's not beat about a bush. Schedule of a certain doctor looks like this. So this doctor, Dr. Jones, I think it is working in the morning, and he's having what we call a morning session. And he also has an afternoon session. And particular things to know is that we know where he works. He works in St. Joseph in these consultation rooms from when the session starts until the session starts. But I actually want to focus on the maximum fill percentage. What's that? Well, basically, when you schedule appointments, you kind of want to have an ability to basically say, well, it's okay for you to overbook what I'm actually giving you to book in, but only up till this percentage. So this was like a true, real invariant you could not break. One of the few ones there are, I would say, in this piece of software. Now let's look at what the code associated with that looks like. So we have this fill percentage class, if you will. that represent the that represents a current fill percentage. And it kind of makes sense that it starts as of 0 and not below, because what's negative fill percentage? I don't know what that is. I mean, not in this domain, actually. So I'm kind of protecting you from doing stupid things. But another thing that happened was that people didn't really like working with decimals. They liked it to specify the full percentage, like 150. So they liked to use the percentage notation instead of the decimal notation. So we had an easy way to go from one to the other. It wasn't fully protecting itself, if you look at it, because we're taking, again, a double value, so it's easy to miss. So maybe we should have beefed up our type system a little bit more, if you will. But let's progress. A maximum fill percentage, on the other hand, started as of 1 or 100%, because it didn't make sense to say, well, you only have a maximum fill percentage of 80%. Why? Well, then make your session smaller. And again, we also take from a percentage notation. Fairly basic stuff, right? Now, what we're trying to achieve is that you don't overbook beyond the maximum fill percentage. So that kind of means that you need to be able to compare your fill percentage to your maximum fill percentage. Now, in C# we have these special interfaces that give you that ability, but translate that to your own language, you'll have something that's, that allows you to do that as well. I didn't point it out earlier, but these, let me go back. These types basically know how to convert themselves implicitly to their primitive value again, their language primitive value, if you will. So when I compare the value of a maximum fill percentage with a fill percentage, what's actually happening is I'm getting the actual value that's in the fill percentage. And that makes this work. And we can get a little bit more sophisticated in how we're going to express that in the rest of our code base. Like we can apply the arithmetic of comparing a value and just overload a bunch of operators, which makes it easier to read, if you will. But we can also embed language into it, and we can actually say, well, does this fill percentage exceed this maximum fill percentage? And we're just leveraging all the other code we've just been writing up until that point. And now we compose it into something bigger, where the session itself is also a value object. So we're adding a time slot to the session, and the time slots are the appointments you've already booked on there, right? So we're adding a new one. But adding a new one just gives you back a new object that is the new session, if you will, with the new time slot added. So it has a property of immutability. It also knows what the maximum fill percentage is for that session, and it has a convoluted way of calculating the current fill percentage. Now we go outside again. I'm bubbling up towards an aggregate at this point, which has a use case of booking a time slot. So what I'm doing is I'm trying to find what session to book this time slot on. And I'm getting it back, and I'm now emulating, well, if I add this time slot, what is the session going to look like? And this is a very important point. I see a lot of people that put their rules in their value objects that constrain their models in ways that are unnatural. In the sense that not all rules should be centralized in that. You can make your model a lot more supple, allow it to answer a lot more questions if you're more careful about where you put your rules. So in this case, booking was not the only thing we allowed, but I could basically use the session as a simulator. Like, what if I add this time slot? What do I get back? How do I compare that? So in this case, after booking, I just compare the current fill percentage to whether or not it exceeds the maximum fill percentage. So I could answer a lot more questions with this same model, with these same value objects, than I could before. And then, in the end, I throw an exception there to kind of notify whoever's calling me that that's not allowed. So for value objects, I mean, I love value objects. I mean, they attract behavior in so many ways in your model that it makes it very easy to know where to place things. I would say to a large degree they are also the primitives of your model, and they keep this repetition that I keep seeing in code bases over and over again, and they put it in one logical place. At least that feels more natural to me. You can also kind of promote domain language, if you will, by using them and by embedding them in their behaviors. And as I said, don't go overboard with putting all the rules in them. Just entertain the idea of taking the rule out and see how your model can help you basically to answer maybe more questions than you used to be able to with less code. Well, they compose well. Like I went from the inside, basically from a fill percentage out to the session, out to an aggregate, basically. So you can basically put different value objects in different places and compose them together to answer a certain question. But there's also a but. Don't do this everywhere. Do this in your core domain. In traditional languages, I'll acknowledge it's a lot of work. It's a lot of work. I've gotten to a point where I'm happy with the pain I need to endure, basically, but I think people that have immutable languages that have immutability and equality inside of them have a much easier time, basically, dealing with these things. And one of the things I keep stressing when I meet teams is that you need to practice this. So you need to do it with the things that are not going to be high value for you to be able to do it when it actually is going to matter. Because not practicing basically doesn't prepare you for when it's actually needed. Again, don't go overboard with it. I mean, if a team is not ready for these types of things, they're more data-oriented, or your problem is more data-oriented, it has no use trying to introduce these type of things. So another topic is testing. Very dear to my heart. And what it means as a practice, I would say, and what kind of local decisions you make there in your tests. Again, the groups thing, so similar domain. I have a module here. I call it behavior module. People familiarized with CQRS will say it's command handler module. People familiar with more traditional will say it's application service. People associated, that have experience with actor models will say, oh, wow, that's an actor to me. Doesn't really matter. I just didn't want to hang up basically on what it actually was. But it represents a piece of behavior where I'm able to execute a certain behavior, and like in this case, starting a private group. And this was a multi-tenant application, so I basically go and figure out, go fetch the tenant, and the tenant would basically be the thing that started the private group. Why? Because there were certain rules embedded in the tenant that, is this tenant still active? Is it already active? So that kind of had a natural home for these things. And again, I'm using the value objects as I did before here. Not that much rocket science, I would say. And then we start looking at a test for that. So when you start a private group, I'm using, I think I'm using Entity Framework here, which is an object relational mapper, but you kind of can see what's going on, right? I mean, I'm setting up that connection to that object relational mapper. I'm adding a tenant, so I'm arranging, basically, there's actually a tenant there. And I'm also arranging that the module that I'm going to talk to is actually properly composed with the proper repositories. And then I'm actually going to send that message, which is starting a private group with this data to the module And in the end, I'm asserting that, hey, a new private group is introduced there. Again, not rocket science. There's something bothering me about tests written this way. There's a lot bothering me about tests written this way. And the main thing that's bothering me is that the how and the what is so intertwined, if you will. So the same test I can write in this way, where I'm saying I'm having a new scenario, and for this particular tenant, here's what that tenant looks like. And now, when I'm executing this, well, when I'm sending this message, which is to start a private group, then I'm going to assert that the private group actually looks like this. All the boring stuff of setting up the ORM and preparing data and comparing data is all tucked away behind the assert there. Doesn't matter how you do the assert to me, is that it's out of sight. This works great with a state-based model, so people writing ORMs just often think, well, we cannot use what the event source guys use. Well, I disagree. So event sourcing looks like this. Just replace the snapshots by event names, right? There's stuff that the state-based model can't do that the event source model can do, but that's not this discussion, let's put it that way. So similar here, you're saying that given that a tenant registered, when I start a private group, then the private group was started. Very simple code to reason about. But there's still something bothering me about this. I mean, we've invested all this time into our value objects, and where are they? I'm just spitting up raw data here. Why not start using the value objects again? So I'm saying, well, this is a tenant ID, this is a subdomain, this is a group ID, this is a group name. And I'm using that data within the same scenario, if you will. And there's another thing happening, and I don't know whether you see it at this point. Do I actually care that it's Nespresso? Do I actually care that it's prototype retail machines? Do I care what tenant ID it is? Do I care what GUID it is? I don't think so. Hey, the clicker isn't working, is it? Oh, it is. So what I can do is basically I can anonymize my data, and I can basically say, well, create me a tenant ID, create me a group ID, create me a group name. I don't care which one it is, as long as it's the valid one. My fixture is what I teach, how to create valid value objects. That's the only place. Imagine changing the rules around your value objects and you're 2 years down the line and you've written like 3,000 tests with literal values. You compile and you have 1,000 broken tests. You're not going to be happy, I think. By moving the construction to one place where you don't really care about what value it is, but it's a valid value, you've just made your test suite much more resilient. There's another property that's being exposed here that you don't see. It is that I can change my model as much as I want. There's no direct coupling to my model at this point. I'm sending messages to a module. However that mechanic works, I can change. Anything that's sitting behind that, I can change. Now, there's also a place where you actually want to test with specific values, but I would say, okay, it's fine to use specific values there, but keep the amount of cases that is to the minimum, I would say. So for testing, I think it's very much about, I mean, even if you don't agree with a particular syntax or have something else in mind, it's about trying to find the level of abstraction that works for you and helps keep your sanity as you grow software over time. And for scenario tests, that very much means that I need to be able to change my implementation code and switch from this type of collection to another type of collection, or a specific object that I'm going to craft to a more generic one, without having to touch your tests. Another thing I think is very important is that trying to assert that only the things that you expected happen and not anything else. So no side effects that you weren't kind of hoping would be there. And again, the boilerplate, keep it out of your tests. It's about the what. It's not about the how, I would say. And as I've shown, value objects and a kind of data generation of fixtures, whether you do test data builders or a specific type of test data generation tool, this basically allows you to decouple your tests from implementation details, I would say, and from specific values. I think a next thing here would probably be something like property-based testing at that point. Okay. Life cycle. We make a lot of local decisions about life cycles, and we're very much unaware of the decisions we're making. We don't make this a very explicit practice, I think. So when you say life cycle, you actually imply time, and you're also implying that there's an identity associated with something over time, and there's particular lenses through which we can look basically at that. Like, is something long-living or short-living? Like, if you entertain all your entities that you're dealing with, in which of these categories do they fit? Is something slow or fast-changing? Are there many of this thing, or is it just, a few of these things? All of these things you can basically associate it with, how am I looking at these things that change over time? We're very much into looking at the beginning of things, but we're very bad at looking at when does something end, because that's usually pushed away and said, well, we'll tackle that problem once the system is in production, and then, you're kind of left with data that's going to be in your system for a long time. Another way of lens to look through is that how things are from a cyclic point of view. Like, somebody triggers something, and then on the clock, something else happens. Versus for other things, it's more like somebody triggers something, and then from then on, each time something completes, the next thing starts going on. And I find this very useful to look at this, not so much because it gives me concrete answers, but it gives me kind of a sense where I'm at with this particular entity that I'm dealing with. Now, life cycle also implies state changes. And what do I mean by that? Well, again, in the similar startup I was in that had this online collaboration, obviously a big part of that was being member of these groups. And there were various ways you could become member of the group. One of them was to kind of request to become a member of the group. And to walk you through it is that, like, you'd basically request to join the group, and then the thing would become requested. And then somebody else would basically pick up and say, well, I'm going to approve this request, or I'm going to decline this request of you. But you yourself could also say, well, actually, I don't want to join this group, so I'm going to cancel my request. And only one of these actually would lead to a membership, which is when it got approved. And visualizing it this way gives you kind of a a way to walk through it, walk through the scenario that you're having, basically. A similar thing we could do for, you could also be invited to join a group, which would be a different kind of life cycle. If you were in the system already, you'd be invited almost directly. If we didn't know about you, some email would be kicked off, basically, and later on, when you actually joined the platform, we'd confirm your identity to that particular invitation, just that we know who you really are within our system. Again, here, you as a person could either accept or reject the invitation, or somebody could basically say, well, no, you weren't supposed to invite this person, and revoke it. So I mean, with this picture, I have the full life cycle, basically, of what this particular thing does and is. Now, the membership life cycle itself would be triggered by the previous ones, where once your membership request was approved or you accepted the invitation, basically, that would basically kick off and initiate your membership. We also had very special behavior that somebody could come in and basically say, I'm taking ownership of this group. But you needed to have special credentials to be able to do that. And again, over the course of time, people would change their role within the group. Somebody would be able to do that. You could say, well, I'm no longer interested to be in this group, so you could cancel it. And then the other thing that could happen is that you've been a bad boy or girl, basically, and say somebody could revoke your membership at that point. So these kind of images are very cool for me to explain it to you, but I wouldn't recommend doing this with, say, a domain expert. They are not very, if you fleshed it out already before you talk to them and you have a good idea of where you want to go, then maybe it can work. But most of the time, it doesn't work that way. Most of the time, you need to have a conversation with them. And the type of conversation I like to have is I create 2 columns, given and then. So let me explain how that works. So you've done your wonderful event storming session, and you got a lot of orange stickies, and you got a lot of blue stickies. Orange stickies represent the facts that have happened. Blue stickies represent the things you can do. With a lot of these things, when you get to the local decisions, you kind of want to bolt down, what exactly am I able to do? That's what the given column is for. The given column is going to say, well, no, that's not what the given column is for. The given column is going to tell you, basically, here's what happened before. The then column is there for you to ask, basically, to the domain expert, so what am I still able to do given this has happened? So you get something like this here. So you start, I mean, obviously you'll fill in the correct commands and events on the sticky notes. And you can, there's multiple ways you can try this out, where you have a long paper scroll and apply this multiple times and not mutate each step basically in your history. Or a different way, it could just be to use your mobile phone and take a picture each time you have a certain outcome. So the way this gets us to these finite state machines is that you're starting to see a pattern, is that given various histories, we're seeing that the blue stickies basically form a cluster, like they're the same over and over again. So that kind of means that we're undiscovering a state that we're in. And then it becomes a question of getting that information out of the domain expert of what would we actually call this? And that kind of gives you this, the names of the states you saw earlier. Now, I admit that was a really simple example there. But for me, this has been a very useful technique to go from how would I say it? To go from a discussion basically to starting the drawing exercise of what that finite state machine may look like. You also have to imagine that the number of permutations in your given and then column is much bigger than on your state machine. What does that look like in code? Well, when I see most people implementing that, it looks a bit like this. They have a lot of Boolean logic around that. Like, I'm having an approve method here on my membership request, and if the membership has already been archived, I'm throwing on you. If it's been declined, same thing. If it's been canceled, same thing. If it's already been approved, I'm doing nothing. And this kind of code permeates into all the other methods that we have. I mean, it duplicates basically very rapidly. And then somebody smart says, yeah, I'll know what we're going to do. We're going to extract the method and put it in there, which is one way of doing it. I mean, that's okay. Another variation I see of it is that people introduce, they sum up the states you can have, basically, and then they start comparing the current state to the state you should be throwing for, or the state you actually want to continue on. So you're kind of imperatively building in your state machine into the rest of your logic, if you will. Now, there's another way of doing this, a much simpler way I find, and that is to actually use a state machine that you've defined declaratively. So you still define your states that you can be in. You also define the triggers, basically. And then when you enter your method, you just say, OK, I want to approve. And then now it's the state machine's responsibility to guard what state transitions can happen and which ones cannot. This is where the value is. Because in each and every method that you're going to implement this, each and every change to that logic you have, to that conditional logic, is going to centralize in one place. And I know it looks like a lot of code, but it's much less code than all the code written all over the place. Now, I've used a specific library here to kind of configure that, where I'm saying for each state, well, if you're in this state, these are the triggers that are permitted. Any other triggers you basically throw on. And I may want to guard in specific ways if you're trying to transition to any of these things. So with that, I think for lifecycle, it's very important to make these things as explicit as you can. And use a lot of visualization. I don't care how you do it, but plot it along the time axis, because that gives you a lot of leverage to communicate with both domain experts and make it clear with peers as well. I would also challenge a lot of the complexity that is often hiding in these life cycles, where people actually say that, yeah, it needs to be like this, but they cannot come up with a concrete scenario. Basically, making a life cycle visual gives you that leverage to have that communication and even simplify things that would otherwise be more complex. I do urge you to consider modeling an explicit state machine, but only if it's warranted. If you have a very simple logic, don't go building a state machine if you can go by with 2 booleans, basically. I mean, don't over-engineer there as well. And that brings me to the end of my talk. I'll take any questions if there are any. There's one there.
Do you sometimes Thanks. You kind of test a given when. Do you sometimes also explicitly test or model some things that may not happen?
Yeah, I deleted that slide. I shouldn't have, probably. Yeah, so you just as well verify also that a certain exception would be thrown or a certain error is returned depending on how your language paradigm is. Yeah, that would be definitely something you would do as well. So you also test the violation of invariance, if you will, at that point.
Invariant based then?
Well, the invariant is implemented, like in C# would be implemented like throwing an exception, and then in your specification you would declaratively say, well, given when then this thing throws this specific exception, I'm expecting this to be thrown. That's what you would be saying.
Okay.
It would have been better with code, wouldn't it?
Isn't that dangerous to use value objects inside events? Because if these events are used as contracts as well.
Yeah, I think how you can perceive that I'm using that, actually that's not what's happening. My events are specified using the primitives of my language, C# in this case. What happens is that the implicit conversion kicks in, and basically the percentage will convert itself to its double value. So I'm using it to seed proper data, but I'm not using it as the value objects are not properties of the message schema. So that's still decoupled, if you will. Okay. And it's a wrap, I guess.
Thank you very much. And don't forget to leave feedback.